Hey guys, okay, so last bit that we're going to do for this exercise is about something called the ratio of the cosines with angles with each axis. I don't know if you remember this from pure in normal maths, that we worked out what the angles that it would make with a particular axis. And we're just going to kind of explore this a bit further. And I'm not really going to do many examples on this. I'm going to just do one example because the exercise sort of gets you to explore these properties as much as you can by yourself. So I anticipate that there may be some questions you kind of want a bit of a hint with or some help with. So please do let me know. Do let me know if there's any videos or any questions that you want me to do some extra work on, okay? So I said, recall from pure year 2 that if a vector A is x, y, z, then from the diagram we can see that cos of alpha is equal to x over the modulus of A, where alpha is the angle between A and the x-axis. So let's just quickly think about what's happening here. So we're trying to find out what angle does it make with the x-axis. This is called the direction cosine. Okay, I should probably just jot this down. We're talking here about they call these things direction cosines. So the angle that it makes with the x-axis is called alpha. If you just look at this triangle that we've got here, it's clearly a right angle triangle. I'm just going to draw it out a bit flatter, where we've got a right angle, alpha. Now this is the vector A, so if I want to change it into a length, I'm going to obviously have to write it in its modulus form. And if we're trying to find out what the angle is, I'm going to try and use this thing that I know here. And this thing that I know here is the x-coordinate of this vector. So that doesn't need taking a modulus because it's just literally the x-coordinate of the vector. And then if you think about setting this up, you can see that cos alpha is equal to the adjacent over the hypotenuse, which is just x over the modulus of A. Now, similarly, what you will see is that cos beta is equal to y over A and cos gamma is equal to z over the modulus of A. Obviously, when we're talking about beta now, beta is the angle with the y-axis, and gamma is the angle with the z-axis. And then we just start noticing some extra properties. This is stuff that technically could have just been in pure maths. It doesn't have to have been in further maths, okay? So a little bit of a reminder, when we see this A with the hat, A hat is the unit vector scaled version of A. So we know that the modulus of A hat is just 1. So remind yourself that A hat is the vector A divided by its modulus. If you need to remind yourself from that, you can go to the Year 12 Vectors playlist just for pure maths, for regular maths, and you can look at the stuff for unit vectors, where you take the vector that you have and you divide it all parts by its magnitude. So you end up with the x part divided by its magnitude, the y part divided by its magnitude, and the z part divided by its magnitude, which happens to be the cosine of the angle it makes with the x-axis. That's what we've just said over here. The cosine of the angle it makes with the y-axis, and the cosine of the angle it makes with the z-axis. So this here are what we call the direction cosines. The direction cosines, we've got cos alpha, cos beta, and cos gamma. And because we know that this thing here is a unit vector, if I was to find the magnitude of this thing, I know the magnitude of this thing is 1. So because the magnitude of this thing is 1, I can get cos squared alpha plus cos squared beta plus cos squared gamma. I'm literally just Pythagorizing this, square rooting it, and getting 1. So you end up with this particular statement that we have down here, that if alpha, beta, and gamma are the angles between a vector A and each of the coordinate axes, then cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. But you will sometimes see this written as L squared plus M squared plus N squared equals 1, where L, M, and N are the cosines of angles with each axis. The cosines of angles with each axis that I'm using here, you'll see these referred to in the textbook and in the questions as the direction cosines. And there are lots and lots of properties that happen here because the L, M, and N, I'm just going to write this out also as L, M, and N. you'll notice that the direction cosines L, M, and N are in the same ratio as the directions of x, y, and z. So there's all these weird properties between these direction cosines and how the vectors actually look. So if you just think, if the line was going like 5, 2, minus 3, then L, M, and N would also be in that same ratio, because we can just see that pattern that we've got here if these two vectors are equal to each other. So I would just read through this again if I were you, because there's quite a bit of information that's packed in here, but it's more just some ideas that will be explored in the exercise. There's going to be lots of odd kind of proofy type questions that they might want you to think about, and I'm more than happy to go through and film some of those for you. So I'm going to pick one of them out as an example that is just kind of weird and how they like to use some other areas of maths for this. So I've got this one here. It says that a line L makes angles of alpha, beta, and gamma with the x, y, and z axes respectively. So they've actually given you the direction cosines that you've got here, and it then wants you to show that cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 1. Well, we know if these are the angles that it makes, alpha, beta, gamma, we know something special. We know this fact down here, and I'm not going to be able to do anything with this just yet, but what I am going to be able to do is I'm going to be able to write this fact out, because it's true. It's true that cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. And we now need to think, how can we go from this to this? Now, don't try and do something super crazy. Just think to yourself from pure maths, what were those things that Mr. Bison tried to get us to memorize? Well, some of the things that I tried to get you to memorize were the rearranged double angle formulae for cosine. So you should know that cos squared A is equal to a half plus a half cos 2A. And if you don't know that, I am actually really annoyed, because I've told you to memorize these things. So I'm just going to use this identity. This question is no longer even really about vectors. It's just about this initial property that we've got down here, or sometimes written in this form, and it's just going to be exploring that. So I'm just going to substitute these things in. Let's go back to my blue colour. So cos squared alpha is going to be the same as a half plus a half cos 2 alpha. Cos squared beta is a half plus a half cos 2 beta, and cos squared gamma is a half plus a half cos 2 gamma, and that is equal to 1. Now you can either multiply everything by 2 now, or we can collect some like terms. So I've got a half, and a half, so that's 3 halves, and 1 minus 3 halves is minus a half, and then I have a half. I'm going to run out of space, so I better do this one over here. I have a half cos 2 alpha plus a half cos 2 beta plus a half cos 2 gamma. Double everything through here, and we get that cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 1, as they wanted. So the questions in the latter part of this exercise are kind of weird that use this direction cosine stuff. They all start off with these ideas that we have on this page. So I really want you to have a go at doing these as much as you can yourself. When you find ones that you can't do, or you get really stuck, either have a look on Solution Bank or drop me a message, and I will record my version of me having a go at it. So that's us just for today's lesson. I want you to try all the questions from exercise 1D, unless some of them get a bit repetitive, in which case you should probably skip a couple of them. But I hope you have a good weekend doing lots and lots of maths, and I will see you guys soon. Bye.